I am at Irving Middle School, and I'm a 6th grader, so y'all are a lot bigger than my little 6th graders, but I'm in a math class and I'm just the same. So I'm not going to be talking something as cool as Noah did, because Fibonacci sequence is actually really cool. But I am going to talk to you about something that y'all should all be familiar with. Who has seen what a radical is? A radical sign. Yeah? Okay, so this is a radical sign. Okay? So radicals. Who can tell me, like, how do you know what, what power this is? Like, how do you know? Okay, how do you know what the index is? It'll have it. Okay, for this one is what? Implied a 2, right? Right? Okay. What is this one? 3. A cube root. And this one? 4. The 4th root. Okay, so we're taking the roots of numbers. So what you probably all have done in your algebra classes are doing like the factors. So let's say we're doing the square root of 18. Okay? So what have you probably done to simplify this? 9. So 9 and 2. Okay, let's factor this out. 9 and 2. Okay, how else can we factor this down? 3 and 3. 3 and 3. Okay, how do we know we're looking for a pair of numbers?
Because it's square.
Square. You know, that 2 right there tells you you're looking to look for a pair. How many is in a pair? 2. Well, looky there. We have 2 right there. So what do we do with these?
Pull them out.
Pull them out. Do we pull out both of them?
Yeah,
just one.
Just one. Why do we pull out just one?
Because
that's the square root. Okay, so I'll help you on that one. Okay, so we're looking for a pair of 3s, right? We're looking for a pair. What do these numbers have the same number?
Yeah.
Yeah? So we only need to take out one of those. So we have 3 square root of 2. That's what we have left, right? We still have this underneath that square root symbol. Right? So we take out a 3, and we have that square root of 2, and we bring it right down there. So that's how we simplify this. Okay? But all of you are very smart people. So this makes sense, doesn't it?
Yeah.
I was just like you. I would go through, my teacher would tell me, this is how you do it. I did it. I got an A. Move on. Right? Okay. But I'm going to show you something that's very conceptually and like what this actually means. What does the square root of a number really mean? So we'll do a couple more factor trees like this. Then we're going to go back and actually show what that is. So what is square root of 75? What do we factor that down to?
3.
What?
Okay,
Okay, factor this, not give me the answer.
25 and 3.
Okay, 25 and 3. 25 and 3. Okay, can this be factored out anywhere?
5 squared and 3.
5 and 5, and we have, bring that down. So what do we have left? We take a pair out. 5 squared root of 3. Okay, we'll do another one. Okay, what do I have left? Okay, square root of 12. What is this factor down to? 3 and 4. 3 and 4? No, it's short. It's slow. Okay. 3 times 4. Now 2 and 2. Okay, so we have a pair.
2.
Woo, we got a pair. Bring that out. So we have 2 square root of what we have left? 3. Oh, don't forget that little symbol. Okay, 2 square root of 3. So is that good on everyone?
Yeah.
Okay, well I'm going to talk about, so my little 6th graders, they don't understand this. They don't understand if you give them a formula and do it, and that's how you do it, right? Because we're all really, y'all are accelerated kids. You'll get this. Well, for those of you that don't, I'm going to show you what this actually means. So, who can tell me, whenever we have a perfect square, give me an example of a perfect square.
36.
36. 81. Okay, so we're going to go up a little bit lower. We're going to go with 9. How do we know how to write a perfect square? What makes a perfect square? Okay, think about the word square. What is a square?
Shape.
Okay, what makes a square?
4 sides.
4 sides.
That are all
equal. Okay, perfect. So, we have 9. We have the number 9. So, if you were in 6th grade, I'd give you all M&M's or something. Sorry, I'm a poor college kid, couldn't do that. But I'd give you all, I'd give you all like M&M's, and you make a square. So let's make our square with pretend M&M's. Right? That's 9. We made it into and 3 on this side, right? Okay, so this whole inside square has an area of what? 9, right? So what would each length of those be? How do you get to that? What's the word I've been using? Square root of 9. That make sense?
Yeah.
Yeah? Okay, how do we make little M&M squares of 7?
You're stupid.
You can. Yeah, you're right. You can. So, let's make it. We have 1, 2, 3, 4, 5, 6, 7. That's as close as I can get, right? So then, I'm trying to teach my little kids, you make squares. It's awesome. That's how you do square roots. But what happens when we get to this problem? Well, that just goes out the window. You can't do that anymore. So, let's think about this. Let's go back to the square root of 18. So, we know that we have a big square, right? And that area is 18. Yeah? Okay. What size were these little beans if we did this and on the grid paper?
1 by 1.
1 by 1. So that square would be 1 by 1, right? Okay? And that would be multiplying together, and that would be 1 times 1 is 1. What if we did this? Let me erase this 18. So we know that this area is 18, right? Okay, what if we made these little squares 2 by 2? Not a 2 by 2. 2 square inches. Not just a 1 square inch, but 2 square inches. How many squares would we have in here?
Oh, God.
9. We'd have 9. So, pardon my drawing. Okay, so that means we have each one of these is 2 square inches. Right?
Yeah.
2 square inches. And 2 times 9 is 18, right? So this whole thing is 18 square inches. What would the side length of each one of these little squares be? Nope, this whole thing is 2. What would this length be? How did we get this one?
Square root of 2.
So what would this one be?
Square root.
Square root of 2. Right?
Yeah.
Okay, we have square root of 2, square root of 2. On the top we have square root of 2, square root of 2, square root of 2. Now how many is this whole length? We have 3 of them, right? How many do we have? 3. So this whole length right here is 3 square root of 2.
I like that.
Yeah, that makes sense, doesn't it?
Yes.
Okay, so now we know that 3 square roots of 2 on each side would get you what? So let's multiply that out. So we have 3 square roots of 2 by 3 square roots of 2, right? That's how we did. Right here we had 1 by 1. We have 3 square roots of 2 by 3 square roots of 2. Let's multiply that out. What's 3 times 3? But Miss Radishak just taught us how to FOIL. So 3 times 3 is what? 9. Okay, what's square root of 2 times square root of 2?
Square root of 4.
Which is 2.
Nice.
Sorry, my bad. Square root of 4. What's 9 times square root of 4? 18. 18. Oh my gosh, that's horrible.
That makes sense.
Okay, so let's go back to, let's look at the square. And this inside is 75.
Okay.
What do you think?
You got this.
How many boxes do you think we're going to have?
A lot.
We're going to have, hold on, let's think about this. Let's think about this.
Have 25 boxes.
So what's on each side? How many? 5 by 5.
Oh, everyone else took credit for that.
Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, how big do you think each box is going to be?
5.
Square root of 5.
Square root of 30.
How many bit? How long?
3.
So we have 25 boxes, right?
3.
How do we get to 75?
3.
5. 3. So each one of these squares.
3 inches.
Okay. So each square is going to be 3 square inches. So what's going to be each length? 5 square. No. What's going to be each
Square root
length?
of 3.
Square root of 3. Square root of 3. Square root of 3. Square root of 3. So how many of these do we have?
5.
5. So we have 5 square roots of 3. Alright, that looks like an S. Okay. 5 square roots of 3. Does that make sense?
Yeah.
That's what we're doing. That's awesome. It makes sense now. Okay, let's do our last one. Slow. So we have a big box. How many boxes do you think we're going to have on the inside?
4.
4. So, how big are each box. How many square units? 3 square units. So, you already told me how big is this length? Square root of 3, square root of 3. We have 2 square root of 3. Okay? Okay, so the last one. This is a little tricky one. I came up with this one at lunch today. So, I really did. Okay.
He's really proud.
Okay, this is a tricky one. I'll give you one hint. Okay, so we have 405. This huge square. How? Okay, I'll give you one hint. Okay, I'll give you one hint. They're gonna have 81 boxes in there. So how many lines do I need to draw?
9.
There's gonna be 81 little boxes.
So 9.
9. Okay, yeah, there's 9. So how big are each box? I'll draw this.
I did.
1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. Okay, it's a 9 by 9. Okay, so how big do you think these boxes are going to be? So there's 81 boxes.
4 points of probability. I'm looking
Do you want me to divide it out?
at you.
Okay, we'll divide it out. We'll do. This is what I'm doing actually. This is what I do in 6th grade. So 4 and 5, long division. We have 81. How many times does 81 go into 4?
0.
0. How many times does 81 go into 40?
Almost 45.
How many times does 81 go into 45? Just shout out 4.
Calculators.
Okay. 6. What's it? We'll try 5. Okay, so 5 times 1 is what? 5. 5 times. Good job, Kate. Yeah, Kate. Yeah, Kate. So, how big are these boxes going to be? 5 square inches. So, what's the length of these? Square root of 5. Square root of 5. So, what's going to be our number? How many do we have now? 9 square roots out of 5. Yeah, isn't that awesome? So, I'm not done yet.
No, I was just proud of your problem.
It's okay. You can clap for me in like 30 seconds. Okay, so I just wanted to show you all that this is what it means when you're doing square roots. So next time you ever think about square roots, this is actually what you're doing. Instead of doing the big long factor tree and finding pairs, that's what you're actually doing. You're just increasing each one of those boxes by like however many you need to do. Okay? Now you may clap.